Scalar multiplication. Now, what do we mean when we say scalar multiplication of a vector? Okay, so that means we are multiplying the vector. We are multiplying the vector by a scalar, number. Now, this scalar number can be from minus infinity to infinity. Okay, so let's take, for instance, I have a scalar number of minus 2 and I want to multiply by the vector x. So let's call this number 1. So that means I'm going to multiply each component. Okay, minus 2 multiplied by x, which is 35. So I'm going to multiply each component of x by minus 2. So this will be minus 2 multiplied by 3, and this will be minus 2 multiplied by 5. So this will give us minus 6 and minus 10. Similarly, if I have, let's say, 2 multiplied by y, now this will become 2, and my y vector is 2 minus 1. So I'm multiplying each component of y by 2. So this will be 2 multiplied by 2, and also 2 multiplied by minus 1. So this will result into 4 and minus 2. Question 3. Let's take, for instance, we have maybe 4 being multiplied by minus 3 and minus 2. Okay, and let's say 4z. 4z. 4 is a scalar, z is a vector. So this simplifies that we have 4 multiplied by the z vector, which is minus 3 minus 2, and we multiply each component. That's 4 multiplied by minus 3, 4 multiplied by minus 2, and this will give us into minus 12 multiplied by minus 12 on the x-axis and minus 8 on the y-axis. And we can also have minus 4 multiplied by z. So that's minus 4 multiplied by minus 3 minus 2, and this will give us minus 4 multiplied by minus 3 and minus 2 multiplied by minus 2, minus 4 rather. And with that done, we have minus 12, okay, or positive 12 and positive 8. So we can write as 12 8. So yes, that is the whole deal on scalar multiplication. So we'll just take a vector, multiply by a scalar number, and then we have an answer. So let's take another combination of vectors. Let's say we have P, okay, we have Q, and then we have R. So let's say P is 1 0, Q is 4 5, and our R is minus 1 minus 3. And we are asked to evaluate the following components of scalar products. So we have 3P as question 2, we have 3Q, okay, or let's say minus 3Q, and then we have question 3, let's say we have minus 4R. Okay, so let's simplify 3P now. 3 is a scalar, okay, P is the vector. So that brings us to scalar multiplication, where we multiply 3 by the vector P. P is 1 0. So we multiply the components of x by 3. So this is 3 multiplied by 1 and 3 multiplied by 0, and we'll have 3 0. And similarly, minus 3Q. So we have minus 3 as the scalar, Q to be the vector 4 5. Vector 4 5. So with that done, we have 4 5, and so we multiply each term. Minus 3 multiplied by 4 minus 3 multiplied by 5, that's minus 12 and minus 15 to be vector 3Q. And question 3 now, which says minus 4 multiplied by R. Okay, minus 4 multiplied by R. Minus 4 is the scalar, R is the vector. Okay, so with that done, we have the scalar minus 4. The vector is R, which is 1 minus 3, minus 1 minus 3. So we multiply each term to give us minus 4 multiplied by minus 1, and the component of y will result into minus 4 multiplied by minus 3, and this will give us 4, and this will give us 12. So now we can see how scalar multiplication is being done. Okay, we multiply a vector by a scalar number, and the scalar number can range from minus infinity to infinity. Now in our next lesson, we will see how we can implement scalar multiplication with addition and subtraction. Let's take, for instance, with this question now, we are required to evaluate 2p plus q. We can also be asked to evaluate, let's say, 3q minus r, or let's say question 3, okay, 2p minus 3q plus 6r. Now we can also say that all this is scalar multiplication, this is addition, scalar multiplication, subtraction, scalar multiplication, subtraction, okay, scalar multiplication, and then we also have addition. So all this we will see in the next lesson.